At the edge of the solar system, two worlds sit billions of miles apart. They are extraordinarily different. One a massive moon wrapped in thick orange haze and methane seas, the other a tiny frozen dwarf planet locked in permanent cold and silence. Scientists have studied both for decades. They thought they knew what was there. Now, the James Webb Space Telescope has found something on both worlds that nobody can explain. One of Webb's most powerful abilities is spectroscopy, splitting light into its component wavelengths to reveal chemical fingerprints. Every molecule in the universe absorbs specific, unique wavelengths of light. When that light reflects off a planet or moon and reaches Webb's instruments, certain wavelengths go missing, absorbed by whatever chemicals are present. Those missing wavelengths are called absorption lines, and they act like molecular signatures telling astronomers exactly what a world is made of. Webb has used this technique to identify water vapor on distant exoplanets, methane in alien atmospheres, and organic molecules in galaxies billions of light years away. The technique works because the relationship between molecules and their absorption lines is precise and universal. The same physics that governs chemistry on Earth governs chemistry everywhere in the cosmos. When researchers studied new Webb data from Titan and Pluto, focusing on small infrared wavelengths that have been relatively unexplored until now, they found something that stopped them cold. At 5.11 micrometers, a specific point in the infrared spectrum, both worlds showed the same absorption line. The same wavelength of light was missing from both Titan and Pluto. The one meaningful thing Titan and Pluto share is their atmospheric chemistry. Both have nitrogen-dominated atmospheres with significant methane. In those conditions, sunlight and radiation can drive complex chemical reactions high in the atmosphere, producing organic haze particles that eventually fall to the surface like chemical snow. The researchers are confident the mystery molecule is located on the surface, not in the atmosphere, but beyond that, the picture gets murky. The team proposed a few candidates. One possibility is benzene, a ring-shaped hydrocarbon known to exist on Titan, mixed with an additional unknown molecule. Another candidate is some form of acetylene or ketene ice, organic compounds that could plausibly form in the cold, radiation-rich environments of the outer solar system. But the researchers are careful. Proving any of these candidates actually produces this specific absorption at this specific wavelength requires detailed laboratory work that hasn't yet been done. The signals also reveal intriguing details about how this molecule is distributed. On Pluto, the absorption line is roughly 3 times deeper than on Titan, suggesting the mystery molecule is considerably more abundant on the dwarf planet. On Titan, the molecule appears unevenly spread, stronger on the trailing hemisphere, the side facing away from the direction of its orbit around Saturn, than on the leading side. That asymmetry is a clue in itself, though what it means remains unclear. For now, the molecule remains unnamed and unidentified. It sits on two worlds that should have little in common, absorbing the same precise wavelength of infrared light, waiting to be understood. It may turn out to be a known compound in an unexpected form. It may be something genuinely new to science. Either answer would be significant, but one of them would be extraordinary. James Webb didn't just find a molecule, it found a question the solar system hasn't answered yet, hidden in a wavelength of light that no one had thought to look at closely enough before.